For almost the whole of human history, we believed the universe had always been here, not created at some particular moment in the scientific sense, and not beginning at all. Simply here, eternal, unchanging, going on forever in every direction and forever backward in time. The stars had always shone. The night sky had always looked more or less as it looks tonight. There was no story to tell about how it began, because it had not begun. It simply was, and that belief was so deep and so old and so nearly universal among the people who thought carefully about such things, that when the evidence finally began to point somewhere else, some of the finest scientists alive resisted it for decades. It felt absurd. It felt almost embarrassing. To say that the universe had a beginning, an actual moment before which there was nothing at all, sounded less like physics and more like theology dressed up in equations. And yet they were wrong, and we now know how the universe began, and over these 3 nights I am going to tell you the whole of it, slowly, gently, from the very beginning of everything. But before we go a step further, let me ask you something softly, because it matters. If these quiet journeys through the great stories of our universe help you set down the weight of your day and drift toward rest, then please take just a moment right now before you settle any deeper and subscribe. It is one small tap, but it means the next of these will find its way back to you on some future restless night when sleep is far away and you need somewhere gentle to put your mind. And it helps, more than you could possibly know, to keep these stories being made, for you and for all the others out there in the dark tonight looking for a little peace. So if you would, subscribe and stay with me, night after night, as we wander together through the great slow stories of how our world came to be understood. And tell me, if you will, from wherever you happen to be resting tonight, in whatever quiet corner of the world is holding you, where are you listening from, and what hour has it reached where you are? Leave it in the comments below. It is a lovely thing to see all the places and all the hours gathered there together, all of us drifting off beneath the same turning sky in 100 different countries and 100 different hours, all of us here in the dark at once. And now, let your shoulders come down, and let your breathing begin to slow. And let us go back to the beginning. And you can understand why the eternal universe was so appealing if you sit with it for a moment. It requires no explanation. A universe that has always existed does not need an origin, and therefore does not raise the awkward question of what came before or what caused it, or why there is anything at all rather than nothing. It simply is, and always was, and the question does not arise. The moment you allow a beginning, all of those questions come flooding in at once, and none of them have comfortable answers. So there was a real intellectual attraction to the eternal picture, quite apart from tradition. It was tidy. It closed the door on a set of questions that nobody knew how to open. There was also a plain practical reason. Nothing in the sky appeared to be changing. The constellations we see tonight are essentially the ones the ancient world saw. The stars have moved a little, but only a little, over thousands of years. Everything up there looked permanent, and had looked permanent for the whole of recorded history, and the reasonable conclusion from that evidence was that it always had been and always would be. And yet that is what we now believe, on very solid evidence, gathered over the last 100 years, that everything, every star and galaxy, every atom in your body, all of space itself, emerged from a single, unimaginably hot and dense state about 13.8 billion years ago, and has been expanding and cooling ever since. We call it the Big Bang, which is a poor name, invented as an insult, and we will come to that story in its proper place. Tonight, and over the nights that follow, we are going to tell the whole of it. How we discovered that the universe is not eternal, how we found out that it is expanding and worked backward from that to a beginning, how the idea was mocked and resisted and finally confirmed by an accident involving a radio antenna and some pigeons, and how we came to know with real confidence what was happening in the first few minutes of everything. It is, I think, the largest story there is, and it is a wonderfully gentle one to fall asleep to, because it is a story about light traveling a very long way through the dark to reach us. And now, let your shoulders come down, and let your breathing slow, and let the whole weight of your day loosen and fall away. Come with me, back a little over 100 years to a time when nobody on Earth knew how big the universe was, or how old, or whether it had ever been any different than it is now. Let us begin with a very old and very simple question, which is one of the loveliest questions anybody has ever asked. Why is the sky dark at night? It sounds like a silly question. The sky is dark at night because the sun has gone down and the sun is what lights the sky. Everybody knows that. But think a little further. Suppose the universe is eternal and infinite. As nearly everyone believed, suppose it goes on forever in every direction, filled more or less evenly with stars, and has done so for all time. Then look up and pick any direction at all, any direction whatsoever. If the stars go on forever, then that line of sight followed far enough must eventually land on the surface of a star. Perhaps a very distant one, but a star. And the same is true of the next direction, and the next, and every direction there is, which means the entire sky, every square inch of it, should be as bright as the surface of a star. The whole night sky should be blazing. There should be no night at all, only a sky burning in every direction, hot enough to cook the earth. And it is not. It is dark, overwhelmingly beautifully dark, with small points of light scattered thinly across it. That is a real problem. And thoughtful people noticed it as far back as the 1600s, and it was named after an astronomer who wrote about it in the early 1800s. Various answers were proposed. Perhaps dust blocks the distant light, though dust would heat up and glow eventually. Perhaps the stars are not spread evenly. None of the answers quite worked. And the true answer, which nobody could have guessed, is the entire subject of these 3 nights. The sky is dark because the universe is not eternal and not infinitely old. It had a beginning. Light travels at a fixed speed, and the universe has not existed long enough for light from everywhere to have reached us yet. There are stars whose light is still on its way and will arrive in 1,000,000 years, and stars whose light will never reach us at all. The darkness of the night sky is itself evidence that the universe began. Rest there a moment and let that sit with you, because I find it one of the most beautiful thoughts in all of science. The oldest, plainest, most ordinary observation any human being has ever made, that it gets dark at night, contains within it the deepest fact about the universe. Every person who has ever lived has looked up at a dark sky. Every one of them was looking at the evidence, and not one of them knew. Now let us come to what people actually thought the universe was, a little over a century ago, because it was very much smaller than the one we live in tonight. If you had asked a good astronomer in about 1900 how big the universe is, you would have received a confident answer. The universe, they would have said, is the Milky Way. That band of soft light across the sky, resolved by telescopes into countless stars, is everything there is. A great flattened disk of stars, some tens of thousands of light years across, with the sun somewhere inside it, and beyond its edges, nothing. Emptiness. That was the cosmos. There was, however, a puzzle in the telescopes. Astronomers had been cataloguing for over a century a class of objects they called nebulae, from the Latin for cloud. They appeared as faint, fuzzy patches of light, not sharp points like stars, and there were thousands of them. Many were clearly clouds of glowing gas within our own star system, and that was fine. But some of them were different. Some were spiral. They had arms curling out from a bright center in an elegant pinwheel shape, and there were a great many of them scattered across the sky, and nobody knew what they were. 2 possibilities were on the table, and they could not both be right. And the difference between them was the difference between 2 entirely different universes. The first was that these spirals were relatively nearby, part of our own star system, perhaps clouds of gas in the process of collapsing into new solar systems. On this view, the Milky Way was still everything, and the spirals were objects inside it. The second possibility was breathtaking. It was that these spirals were not in our star system at all, but were themselves enormous collections of stars, entire star systems like our own, unimaginably far away, so distant that all their billions of stars blurred into a single faint smudge. Island universes, as the phrase went at the time. If that were true, then the Milky Way was not the universe. It was one object among countless others, scattered through a cosmos vastly larger than anyone had dared to imagine. The argument came to a head in 1920, at a formal debate held in Washington. which has come to be known as the Great Debate. Two respected astronomers presented the opposing cases before an audience of their peers. It was, by all accounts, a polite and inconclusive affair, and neither side won, because the crucial piece of evidence was missing. It is worth pausing on that debate for a moment, because it is such a human scene. Two careful, serious, thoroughly professional men, each with a great deal of evidence on his side, each entirely convinced, arguing in a lecture hall about whether the universe is one thing or 100 billion things. One of them argued that our star system was enormous and contained everything. The other argued that our star system was more modest and that the spirals lay far beyond it. And here is the part I find rather touching. Each of them was right about some things and wrong about others. The one who was wrong about the spirals was right that our galaxy is much larger than had been thought. The one who was right about the spirals was wrong about the size of our own galaxy. Neither man walked away with a clean victory, and neither deserved one because nobody yet had the measurement that would settle it. That is what the edge of knowledge actually looks like from the inside. Not a clear division between the correct and the mistaken, but two thoughtful people, each holding a mixture of truth and error, waiting for a fact that has not arrived yet. Distance. Everything depended on distance. If you could measure how far away a spiral was, the question would answer itself immediately. If it were a few thousand light years away, it was inside our star system. If it were 1,000,000 light years away, the universe was enormous and full of galaxies. And measuring distance in astronomy is fiendishly difficult, and this is worth explaining, because it is the crux of the entire story. Look up at the night sky. You see points of light, some brighter, some dimmer. But brightness tells you nothing on its own, because a bright point could be a modest light nearby or a brilliant light far away, and there is no way to tell the difference by looking. Imagine standing on a hill at night, looking out over a dark landscape scattered with lights. Is that a candle in a nearby window or a searchlight on a distant mountain? You cannot say unless you know something about the light itself, but if somebody tells you that a particular lamp is a standard street lamp of a known and fixed brightness, then everything changes. Now you can compare how bright it appears to how bright you know it truly is, and from the difference, you can calculate exactly how far away it must be. That is what astronomers needed. A standard candle, some kind of object recognizable that always shines with the same known brightness, so that its apparent dimness reveals its distance. And the person who found the first good one is one of the most quietly remarkable figures in the history of science, and for a long time, almost nobody outside astronomy had heard of her. She worked at an observatory in Massachusetts at the turn of the last century, as one of a group of women employed to do the painstaking work of examining photographic plates of the sky. They were called computers, which in those days meant a person who computes. They were paid very little, well below what a man doing the same work would have received. They were largely forbidden to operate the telescopes themselves. They measured, catalogued, and calculated for years, and the great majority of them received almost no credit for what they found. And what a group of them it was, in hindsight. That room produced a startling amount of the foundation of modern astronomy. One of them devised the system for classifying stars by their spectra that is still in use across the world today, and catalogued several 100,000 stars by hand. Another worked out what stars are actually made of, and found that they are overwhelmingly hydrogen, which contradicted the settled wisdom of the day so completely that she was pressured into softening her conclusion in her own thesis, and was proved right a few years later. They worked 6 days a week, examining glass plates by eye, hour after hour, recording numbers in ledgers. Photographs of that room survive, and they show a long table with women seated along both sides of it, bent over their plates, with magnifying glasses and pencils, in the high-collared dresses of the period. It is worth holding that image alongside the usual picture of astronomy, the lone genius at the eyepiece under the stars. A great deal of what we know about the universe came out of that room, from women who were not allowed at the eyepiece at all, and who were paid a few cents an hour to look at glass. She was assigned to study variable stars, stars whose brightness rises and falls in a regular cycle, and in particular a group of them in 2 small companion star clouds, visible from the southern hemisphere. She measured thousands of them. and she noticed something that nobody had ever seen. Among a certain class of these pulsing stars, there was a relationship between how long the pulse took and how bright the star was. The brighter ones took longer to cycle, the dimmer ones cycled faster, and the relationship was clean and regular and mathematical. Now, why did that matter so enormously? Because all of the stars she was studying were in the same cloud, and therefore all at roughly the same distance from us, which meant that differences in their apparent brightness were real differences in actual brightness, not differences in distance. So she had found a way to know a star's true brightness just by timing its pulse. Watch the star. Time how long it takes to brighten and dim and brighten again. That tells you how much light it is truly giving off. Compare that to how bright it appears to be, and the difference gives you the distance. She had found the standard candle. She had given astronomy its measuring stick. Rest a moment there gently because she deserves it. She published that relationship in 1912 in a short paper under her supervisor's name, with a note acknowledging that the work was hers. She was in poor health for much of her life and increasingly deaf. She died of cancer at 53 in 1921 before the full consequences of what she had found had become clear. 4 years later, a mathematician from Sweden wrote to the observatory intending to nominate her for the highest prize in physics, and was told that she had already been dead for several years, and the prize is not awarded posthumously. Everything that follows tonight, and much of what we know about the size and age and history of the universe, rests on the relationship she found by carefully measuring photographic plates for years, in a room where she was not permitted to use the telescope. Now, armed with her method, astronomers could finally attack the question of the spirals, and the man who did it had access to the finest telescope in the world. He was a large, athletic, ambitious American, a former lawyer and boxer who affected an English accent and an English manner and told a great many exaggerated stories about his own life. He was not, by most accounts, especially easy to like. He was also an extraordinarily gifted observer, and he was working with a new 100-inch telescope on a mountain in California, the largest in the world at the time. In 1923, he was photographing the great spiral in the constellation of Andromeda, looking for exploding stars, when he spotted a point of light on a plate that he first marked as a nova. Then he checked it against earlier plates and realized his mistake. It was not an exploding star. It was one of her pulsing variables. He crossed out his note on the plate and wrote a single word above it, var for variable, and he drew an exclamation mark beside it. That plate still exists, with the crossing out and the exclamation mark, and it is one of the most famous objects in the history of astronomy, because in that moment the universe got very much bigger. He timed the pulse. He applied her relationship. He calculated the distance. The answer was so large that at first it seemed impossible. By his initial reckoning, that spiral was hundreds of thousands of light years away, far beyond any possible edge of our own star system. Later and better measurements pushed it further still, to about 2.5 million light years. The spirals were not clouds inside our galaxy. They were galaxies, each one an enormous collection of billions of stars, at distances so vast that the numbers stop meaning very much. And there is a consequence of those distances that is worth a moment, because it changes what looking at the sky even means. Light is fast, but it is not instant. It takes about a second and a bit to come from the moon, so when you look at the moon, you are seeing it as it was a moment ago. Sunlight takes about 8 minutes, so the sun you see is always 8 minutes old. The nearest stars are years away, so their light left before you last had a birthday. And that great spiral in Andromeda is 2.5 million light years away, which means the light entering your eye, if you go outside on a dark night and find that faint smudge, left it 2.5 million years ago. It set out when there were no human beings on this planet, only our early ancestors, walking in Africa, making the first stone tools. That light has been traveling the whole time. It crossed the emptiness for 2.5 million years and ended its journey in the back of your eye. You cannot see the universe as it is. Nobody can. You can only ever see it as it was. And the further away a thing is, the deeper into the past you are looking. A telescope is not merely a device for seeing distant things. It is a device for seeing old things. point it far enough, and you are looking at a young universe. That fact will matter enormously later in this story. Hold on to it. When we eventually come to the oldest light of all, it will be this same idea, taken as far as it can possibly go. And there were thousands of them visible in the telescopes, which meant there were certainly millions more beyond. And it eventually became clear that there are something in the order of 2 trillion galaxies in the observable universe. Rest there a moment and try to feel the size of that shift, because it is one of the great expansions of the human mind, and it happened within the lifetime of people, some of whose grandchildren are still alive. In 1920, the universe was one galaxy, and we were in it. By 1925, the universe was unimaginably vast, and our entire galaxy, everything anyone had ever seen or catalogued or wondered about, was one faint smudge among an uncountable multitude of others. Every star you have ever seen with your own eyes belongs to a single one of those 2 trillion. That is a demotion if you want to look at it that way, but I have always found it the opposite. The universe turned out to be so much larger and so much more full of wonders than anyone had dared to hope. What was lost was a small, tidy cosmos. What was gained was everything. But the greatest discovery was still to come, and it came out of the same telescope within a few years, and it was the thing that broke the eternal universe apart. To understand it, we need one more idea, and it is a simple one that you already know from ordinary life. You have heard an ambulance go past. As it approaches, the siren sounds higher in pitch. As it passes and moves away, the pitch drops. The sound is not actually changing. The siren is doing exactly the same thing throughout. What changes is that the motion of the source squeezes the sound waves together as it comes toward you, raising the pitch, and stretches them out as it goes away, lowering it. Light does the same thing. If a source of light is moving toward you, its waves are squeezed slightly, shifting the light toward the blue end of the spectrum. If it is moving away, the waves are stretched, shifting the light toward the red. And astronomers can measure this with great precision, because starlight spread out into a spectrum carries a pattern of dark lines in it, produced by the elements in the star's atmosphere, absorbing particular wavelengths. Those patterns are fixed and known from laboratory work here on Earth. So if you photograph the spectrum of a distant object and find the whole familiar pattern shifted toward the red, you know immediately that the object is receding, and by how much the pattern has shifted, you know how fast. Now, another astronomer had already been doing exactly this work patiently for over a decade at an observatory in Arizona, long before anyone knew what the spirals were. He had photographed the spectra of dozens of them, an extremely difficult task with the equipment of the time, requiring exposures lasting many nights. And that work deserves more admiration than it usually gets. So let me describe what it actually involved. To photograph the spectrum of a faint fuzzy object, you must gather its light and spread it out into a rainbow before recording it, which spreads a very small amount of light very thin. With the photographic materials of that era, a single spectrum of a single spiral could require 20, 30, 40 hours of exposure. And you cannot expose for 40 hours in one go because the sun keeps rising. So he would open the plate for a night, close it, store it in the dark, and open it again the next clear night, and the next, and the next, keeping the telescope tracking the same faint smudge to the same fraction of a degree each time, for weeks. One object, weeks of work, and at the end of it, a small strip of glass with some faint dark lines on it. He did that over and over, year after year, and built up the first collection of galaxy velocities in history, at a time when nobody even knew whether these objects were nearby clouds or distant island universes. And he had found something baffling. Almost all of them were redshifted. Almost every spiral he measured was moving away from us, and many of them at enormous speeds, far faster than anything else known in the heavens. Nobody knew what to make of it. It was a strange fact without a home, sitting in the literature, waiting. And then, in the late 1920s, the man on the mountain in California combined the two things. He had the distances from her pulsing stars, and there were the velocities from the redshifts. He plotted one against the other, and the points fell, roughly but unmistakably, along a straight line. The further away a galaxy was, the faster it was receding. Twice as far, twice as fast. 10 times as far, 10 times as fast. A clean, simple, proportional relationship holding across the whole sky. Rest there a moment and let us think carefully about what that means, because it is the hinge of everything, and it is easy to picture it wrongly. Your first thought might be that we are at the center of some enormous explosion, with everything flying away from us. That would explain why everything is receding, but it does not explain the proportionality, and more importantly, it puts us in a very suspicious position at the middle of the universe, which every previous such assumption in the history of astronomy has turned out to be wrong. The real explanation is stranger and far more elegant. The galaxies are not flying apart through space. Space itself is expanding and carrying them along with it. Let me give you the picture that is usually used because it works well. Imagine a loaf of raisin bread dough with raisins scattered evenly through it, rising in a warm kitchen. As the dough expands, every raisin moves away from every other raisin, not because the raisins are moving through the dough, but because the dough between them is growing. And now notice something. Pick any raisin and look out from it. Its nearest neighbors drift away slowly because there is only a little dough between them to expand. A raisin far across the loaf recedes much faster because there is a great deal of dough between them, and all of it is expanding at once. The further away, the faster the recession, exactly proportional to distance. And here is the loveliest part. It looks exactly the same from every raisin. Every single one of them sees all the others moving away, with the distant ones moving fastest. And every single one of them appears from its own point of view to be at the center. And not one of them is, because there is no center. The whole loaf is simply getting bigger everywhere at once. That is our universe. We are not at the center of the expansion. There is no center. Every galaxy in existence sees what we see, and any observer anywhere would draw the same graph and reach the same conclusion. Two things are worth clearing up here because they trip almost everyone. The first is that the expansion is not pushing things apart in the way an explosion does. Nothing is flying outward from anywhere. There is no debris. The galaxies are, broadly speaking, sitting still. It is the space between them that is growing, which sounds like a distinction without a difference and is actually the whole point. The galaxies are not moving away from us through space. More space is appearing between us. The second is that this does not happen everywhere. It does not happen inside things that are held together. The Earth is not expanding. Your body is not expanding. The solar system is not expanding, and neither is our galaxy, nor the small local group of galaxies to which we belong. In all of those places, gravity and the other forces are perfectly capable of holding things together against the stretching, and they do. The expansion only wins out in the vast emptinesses between clusters of galaxies, where there is so much distance and so little matter that nothing is holding on. Out there in the enormous voids, space quietly grows, so there is no need to picture the room around you slowly swelling, or the distance to your window creeping up overnight. It does not work like that. The expansion is a story about the very large and the very empty, and everything close and solid and warm around you is quite firmly held. Rest there and take a breath, because that discovery, published in 1929, ended a belief that had stood for the whole of human history. The universe is not static. It is not eternal and unchanging. It is growing. Every day, the distance between distant galaxies is greater than it was the day before. The cosmos is not a place, it is a process, and it is happening right now, everywhere, including in the empty space between you and everything you can see. And once you know that, one obvious and unavoidable question arrives, and it is the question that this whole series exists to answer. If everything is moving apart, then yesterday everything was closer together, and the day before closer still. Run the film backward far enough, and everything you can see must once have been packed into a very small space indeed, which means it began. That question, and the extraordinary resistance it met, and the priest who first dared to answer it, and the mocking nickname that stuck, is where we will go next time. But not tonight. Tonight, let the story rest here, at the moment the universe stopped being eternal. With the plates drying in the darkroom on a mountain in California, and a graph with a line through it, and nobody yet quite willing to say out loud what it meant. So let your breathing slow, and let the dark night sky, and the woman measuring plates in a room where she was not allowed to touch the telescope, and the exclamation mark scrawled on a photograph, all grow soft and dim and far away. It was all so recent in the great scheme of things, barely 100 years, and yet every one of them has long since laid down their work and gone to their rest, having handed the question on, as we all do, to the ones who came after. There is nothing here you need to hold or carry tonight. It is only a story about people patiently measuring points of light on glass plates until the universe turned out to be far larger and far stranger than anyone had imagined. And here is a thought to take down with you, if you would like one. Every one of those 2 trillion galaxies is out there tonight, right now, turning slowly, full of stars, most of them with worlds going around them. Not one of those galaxies knows we are here. Not one of them requires anything from us. They were there before anybody looked, and they will be there long after. There is a great deal of room out there, more than anyone imagined 100 years ago. And you are lying tonight, in one small warm corner of it, which is exactly enough. And it is still expanding right now tonight, quietly, in every direction, in the great emptiness between the galaxies. It has been doing that for 13.8 billion years without pause. It will carry on while you sleep gently, without needing anything from anyone. Sleep now, warm and safe and held, on a small world in a small galaxy, under a sky that is dark for the best of all possible reasons. The story will still be here tomorrow and the night after, and we have all the time in the world to follow it, gently, together, all the way back to the beginning. Everything is moving apart. So yesterday everything was closer together. That is where we left the story, and it is such an obvious thought that it seems almost too simple to be important. If the distances between the galaxies are growing, then they were smaller before. And smaller before that. Run the film backward far enough and everything you can see, every galaxy, every star, every atom, must once have been crowded into a very small space indeed. It follows in a single step from what had just been measured. A child could reason their way to it. And yet, when the first person actually said it out loud and worked out the mathematics, the greatest physicist in the world told him to his face that his physics was abominable. Tonight we find out why. Tonight is the story of the most resisted idea in modern science, of the rival theory that fought it for 20 years, of the insulting nickname that ended up on the front of every textbook in the world, and of the 2 engineers who accidentally proved the whole thing while trying to get rid of some pigeons. But before we go a step further, let me ask you something softly, because it matters. If these quiet journeys through the great stories of our universe help you set down the weight of your day and drift toward rest, then please take just a moment, right now, before you settle any deeper, and subscribe. It is one small tap, but it means the next of these will find its way back to you on some future restless night, when sleep is far away and you need somewhere gentle to put your mind. And it helps, more than you could possibly know, to keep these stories being made, for you and for all the others out there in the dark tonight, looking for a little peace. So if you would subscribe and stay with me night after night as we wander together through the great slow stories of how our world came to be understood. And tell me, if you will, from wherever you happen to be resting tonight, in whatever quiet corner of the world is holding you, where are you listening from? And what hour has it reached where you are? Leave it in the comments below. It is a lovely thing to see all the places and all the hours gathered there together, all of us drifting off beneath the same turning sky, in 100 different countries and 100 different hours, all of us here in the dark at once. And now, let your shoulders come down, and let your breathing slow, and let the whole weight of your day loosen and fall away. Come with me back to the 1920s, to a universe that has just started expanding and that nobody wants to admit had a beginning. Let us begin with the man who did not want the answer he found. We spoke in an earlier series about the reimagining of gravity as the bending of space and time, when the man who devised that theory applied it to the universe as a whole. In 1917, he found something he did not like at all. His equations said the universe could not sit still. Gravity pulls everything toward everything else, so a universe full of matter, left alone, must either be collapsing under its own weight or expanding against it. It cannot simply hang there unchanging and eternal, because gravity would not allow it. The mathematics was quite clear about this, and he did not believe it. Like everyone else at the time, he was certain the universe was static, because that is what it plainly looked like and what everyone had always assumed. So he did something that he would later call the greatest blunder of his life. He added an extra term to his equations, a sort of counterbalancing pressure built into empty space, tuned precisely to hold everything still against gravity. It was not crazy. Nothing in the theory forbade such a term, but he put it there for the wrong reason, not because any evidence demanded it, but because he wanted the answer to come out static, and it would not. Rest a moment there, because this is a very human thing, and it happens more than we like to admit. He had a theory that was telling him something extraordinary and true, and he did not trust it because it disagreed with what everybody knew. So he adjusted it until it agreed. It is one of the great cautionary tales in science, and the man himself was quite open about the shame of it afterward, once the expansion had been measured. And it is worth being clear about what he actually missed, because it is rather poignant. He had in his hands in 1917 a theory that predicted the expansion of the universe, 12 years before anybody measured it. He could have announced it. He could have said, "My equations say the universe must be changing in size, go and look." It would have been the greatest prediction in the history of astronomy, and when the redshifts came in, it would have been confirmed spectacularly. Instead, he suppressed it, because it did not match what everyone believed. He preferred to modify the most beautiful theory he ever produced, rather than doubt an assumption that had never actually been tested. There is a lesson in that which is worth carrying past this story, and it is not really about physics. The hardest thing to question is never the evidence in front of you. It is the assumption behind you, the one so old and so universal that it does not even feel like an assumption. It just feels like the way things are. There is a lovely final twist to that, incidentally, which we will come to in our last night, because that extra term he invented and then retracted in embarrassment has turned out to be real after all, though not for the reason he thought. Now, a few years later, a Russian mathematician looked at those same equations without any preconceptions, took out the artificial term, and simply asked what the mathematics allowed. And he found a whole family of solutions describing universes that expand, universes that contract, universes that expand and then fall back. He published this in the early 1920s purely as mathematics, without claiming that any of it described the real world. The great man himself initially responded in print that the work contained an error. Then he checked it again and had to publish a correction admitting that the mathematics was correct after all, though he added that the expanding solutions were hardly of physical significance. The Russian died of typhoid in 1925 at 37 and never learned that his solutions described the actual universe. And so we come to the person who is really the hero of tonight, and he is one of the more unusual figures in the history of science. He was Belgian. He had served as an artillery officer in the First War, in the trenches, and had been decorated for bravery. Afterward, he studied physics and mathematics, and he also entered the priesthood and was ordained. He spent the rest of his life as both a Catholic priest and a working scientist, and he was very insistent, all his life, that the two things must not be mixed. Science answers questions about how the physical world works, and it must be argued entirely on evidence and mathematics, and religious belief has no business putting its thumb on that scale. That insistence turns out to matter a great deal in this story, because his idea would be attacked from both directions by people who thought it was religion disguised as physics. In 1927, 2 years before the Great Measurement was published, he worked out for himself that the universe should be expanding, derived a relationship between how far away a galaxy is and how fast it recedes, and even estimated the rate using the scraps of data available at the time. He published it in a small Belgian journal in French where almost nobody read it. And then he did the thing that nobody else was willing to do. He kept going backward. If the universe is expanding, he reasoned, then trace it back and everything converges. Not just closer. Closer and closer without limit, until all the matter and energy in existence is concentrated into a single point of unimaginable density. And that state, he proposed, was the beginning. He called it the primeval atom and sometimes the cosmic egg, a single quantum containing everything, which decayed and fragmented, and whose pieces became the universe. He published that in 1931, and he added something quite bold for the time, which is that this beginning would have been a real physical event with real physical consequences, and that we might be able to find traces of it still lying around, which is precisely what would eventually happen 30 years later. Now, the reaction. He met the great man at a conference and explained his idea. And the reply he received has become famous. "Your calculations are correct," he was told, "but your physics is abominable. Rest a moment with that, because it is such a striking sentence. Not, you have made an error. The opposite. Your mathematics is fine. I simply refuse to believe that the universe behaves that way." And it was not only him. The resistance was broad and it was deep, and it lasted for decades. And it is worth understanding where it came from, because it was not stupidity. Part of it was the sheer strangeness. A universe with a beginning raises questions that physics did not know how to handle. What came before? What caused it? Why then and not some other time? An eternal universe has none of those problems. Part of it was that the numbers did not work at first. Early estimates of the expansion rate were badly off, and when you used them to calculate how long ago everything had been together, you got about 2 billion years. And geologists had already established from rocks that the Earth was older than that. So the theory appeared to say that the universe was younger than the planet inside it, which is obviously impossible. That was a serious and legitimate objection, and it took years and much better measurements to resolve. And it turned out the distance scale had been wrong. And part of it, frankly, was suspicion about the priest. A universe with a moment of creation proposed by a Catholic priest looked to some scientists like theology sneaking in through the back door. That suspicion was unfair, and he resented it, and he pushed back on it firmly for the rest of his life. There is a striking episode much later, in the 1950s, when the Pope of the day gave a speech enthusiastically declaring that the new cosmology confirmed the doctrine of creation. And the priest was not pleased at all. He worked quietly behind the scenes to persuade the papacy to stop making that argument, on the grounds that a scientific theory should never be used as religious proof, because a scientific theory can be overturned by evidence and faith should not be hostage to that. He is said to have been largely successful. Rest there a moment, because I find that admirable. He had every worldly reason to accept the endorsement. The head of his own church was publicly declaring that his theory proved his religion, and he went and asked him to stop because he thought it was bad for science and bad for faith. That is a person with a great deal of integrity, and it is worth admiring quietly at the end of a long day. So the idea was on the table, and it was not popular, and it needed something to fight. And what it got in the late 1940s was a serious and elegant rival, put forward by 3 astronomers in Cambridge, and it kept the argument alive for 20 years. Their idea was called the steady-state theory, and it was in its way beautiful. They accepted the expansion. The measurements were solid, and there was no arguing with them. But they refused to accept a beginning, and they found a way to have both. Suppose, they said, that as the universe expands and the galaxies drift apart, new matter comes into existence in the empty spaces between them. Not much. A few atoms of hydrogen per cubic kilometer per year would be quite enough. Far too little to detect, but over cosmic time, enough new matter to form new galaxies in the gaps, so that the average density of the universe never changes. On that picture, the universe expands forever and always looks the same, and has always looked the same, and always will. There is no beginning and no end. It is eternal, and it is expanding, and both at once. They called this the perfect cosmological principle. The universe looks the same everywhere, and also at all times. And there is something quite appealing in that, philosophically, which is worth a moment. One of the recurring lessons of astronomy had been that we are not special. The Earth is not the center of the solar system. The Sun is not the center of the galaxy. Our galaxy is not the center of the universe. Every time somebody had assumed we occupied a privileged position, they had turned out to be wrong. So these astronomers took that principle and extended it to time as well. Why should we be living at a special moment? Why should we happen to exist relatively near the beginning of things, in an era unlike all the eras that came before and will come after? Surely, they argued, the honest assumption is that our moment is not special either, and the universe has always looked roughly as it does now and always will. It is a very good argument. It is the same reasoning that had been right every previous time it was applied, and it happened to be wrong. We do live at a special time, in the sense that the universe was once very different and will one day be very different again, and the era of galaxies and starlight is a passing phase. Sometimes the reliable principle fails, and the only way to find out is to go and look. And I want to be fair to it, because it is often treated as a joke in hindsight, and it was nothing of the kind. It was a serious theory by serious people. It explained the expansion. It avoided the awkward beginning. It avoided the age problem that was embarrassing the rival theory at the time. And crucially, it made testable predictions, which is what a real theory does. Its leading champion was one of the most brilliant and original astrophysicists of the century, a man who would later do truly great work on how the elements are forged inside stars. He was also combative, and he loved an argument, and he had a gift for the memorable phrase. And in 1949, giving a talk on the radio, he was explaining the opposing view, the one with a beginning, and he described it as the hypothesis that all the matter of the universe was created in one big bang at a particular time in the remote past. One big bang. He always denied that he meant it as an insult, and said he was simply reaching for a vivid image for a radio audience. Others who knew him were quite sure there was a sneer in it. Either way, the name escaped immediately, and it spread, and it stuck, and it became the permanent official name of the theory he spent his life opposing. Rest a moment on that, because it is one of the great ironies in the history of science. The man who fought the theory hardest, for the longest, and who never accepted it even at the end, is the man who named it. Every textbook in the world now uses the phrase he coined to mock it. And the name is a poor one, incidentally, and cosmologists complain about it constantly because it gets two things wrong. It was not big, since everything that exists was involved, and there was no outside for it to be big compared to. And it was not a bang, because there was no sound and no explosion into surrounding space. It was space itself, everywhere at once, beginning to expand. There was a competition once to find a better name, with thousands of entries, and the judges concluded that none of them were any improvement, and Big Bang it remains. So through the 1950s, the two theories fought, and it was a real fight. Conducted in journals and lecture halls and on the radio, with both sides producing arguments, and neither able to land a decisive blow, because the observations were not yet good enough to tell them apart. What was needed was a prediction that only one of them made. Something you could go and look for that would exist if one theory was right and not if the other was. And such a prediction had already been made and published and almost entirely ignored. In the late 1940s, a physicist working in America, a Russian emigrant with a great sense of humor and a serious mind, had been working with his student on what would actually happen in the first moments of a hot, dense beginning. Their reasoning went like this. If everything was once packed together, it must have been unimaginably hot because compressing things heats them up. So the early universe was not just dense, it was a furnace, hotter than the inside of any star. So hot that atoms could not exist because any atom would be instantly smashed apart. So hot that the whole universe was a glowing plasma of bare particles and radiation, opaque like the inside of the sun everywhere. Now let it expand. As it expands, it cools, the way any expanding gas cools. And at some point, after a few 100,000 years, it cools enough that atoms can finally hold together. The bare particles combine into neutral atoms, and at that moment, something dramatic happens to light. In the hot plasma, light could not travel freely because it was constantly scattering off loose charged particles. It was trapped, bouncing endlessly, and the universe was foggy. But once the particles combine into neutral atoms, the fog clears. Suddenly, light can travel freely across space without being scattered. And all of that trapped light, all of it, is released at once, everywhere in the universe simultaneously, and begins to travel. And it has been traveling ever since. Nothing has stopped it. It is still traveling right now in every direction, filling all of space. It cannot have gone anywhere, because there is nowhere for it to go. The universe is full of it. And here is the part that ties back to something we said on our first night, and it is worth taking slowly, because it is one of the strangest and most beautiful facts about the sky. Remember that looking far away is looking back in time, because light takes time to travel. Look at the moon and you see it a moment ago. Look at a distant galaxy, and you see it as it was millions of years ago. So keep going. Look further and further out, and you see further and further back, to younger and younger galaxies, to a time before galaxies had properly formed. Back, and eventually in every direction, you reach the fog. Because before that moment when the atoms formed, the universe was opaque. Light could not travel. So there is a limit to how far you can see, and it is not a limit of telescope power. It is a wall in time. You can see back to the moment the fog cleared, and not one instant further, in any direction ever, no matter what instrument you build. And that wall is what those two engineers were hearing. The oldest light there is, the surface of the fog, seen from inside, 13.8 billion years later, glowing faintly from every direction at once. It is sometimes said that the universe has an edge, and people picture a boundary out in space somewhere. That is not it. The edge is not in space, it is in time. We are surrounded in every direction by the moment the universe became transparent, and we cannot see past it, and neither can anybody else, anywhere. But the universe has expanded enormously since then, and when space stretches, the light traveling through it stretches with it. So those waves have been drawn out longer and longer over billions of years, shifted far past red, past infrared, all the way down into microwaves. What was a blinding white-hot glow has been stretched into a faint whisper of microwave radiation, at a temperature just a few degrees above absolute zero. They calculated all of this, and they published it, and they predicted that this leftover glow should still be detectable today, coming from every direction in the sky. And essentially nothing happened. It was a prediction of a subtle signal, at a time when the equipment to detect it barely existed, in support of an unpopular theory. It sat in the literature for 15 years, and the people who might have gone looking for it either did not know about it, or did not think it worth the trouble. Rest there a moment and hold that, because it is the second time in this series that a crucial piece of work has simply sat unread. The universe had left us a message, and somebody had worked out exactly where to look for it, and had written it down and published it, and nobody went and looked. Until, in 1964, two radio engineers in New Jersey found it entirely by accident, while trying to solve what they believed was an equipment problem. They were working at a research laboratory belonging to a telephone company, with a large horn-shaped antenna that had been built for early satellite communication. They wanted to use it for radio astronomy, which required them to understand every last source of noise in the system, because the signals they hoped to study were extremely faint. It is worth picturing the thing because it was not a telescope in any sense you would recognize. It looked like an enormous metal ear, a great horn some 15 meters long, mounted on a frame on a hill in New Jersey, pointing up at the sky. It had been built to bounce signals off the first communication satellites, and by the time these two got hold of it, that work had moved on, and the instrument was available for research. They were careful, methodical people, and their whole approach was about eliminating noise. That is what a radio astronomer spends most of their life doing. The signals from space are so faint that everything else drowns them. So before you can measure anything at all, you must account for every source of interference there is. The warmth of the atmosphere, the heat of the antenna's own metal, the electronics, the nearby city, everything. So they set about eliminating the noise, and there was a hiss, a faint, persistent background hiss, present in the data no matter what they did. They checked everything. They checked their electronics, their amplifiers, their connections. They pointed the antenna in different directions, and the hiss was the same in every direction, which was strange in itself, because real sources are localized. They pointed it at the sky at different times of day and different times of year, and it did not vary, which ruled out the sun, our galaxy, and anything in the solar system. And then they found the pigeons. A pair of them had been roosting inside the horn of the antenna and had covered part of the interior in what the two engineers described, in the polite language of a technical paper, as a white dielectric material. They were delighted. Here at last was the culprit. They removed the pigeons, cleaned out the antenna thoroughly, and ran the measurements again. The hiss was still there. Exactly the same. They spent about a year on this, patiently eliminating every possibility they could think of, and the hiss would not go away, and they had no idea what it was. It was not coming from the equipment. It was not coming from the Earth, or the Sun, or the galaxy. It appeared to be coming from everywhere in the sky at once, equally, all the time. Meanwhile, some 50 kilometers down the road, a group of physicists at Princeton had independently rediscovered the old prediction and had reached the conclusion that a hot beginning should have left behind a faint microwave glow. They were at that moment in the process of building an antenna to go and look for it. A phone call was made between the two groups, and the physicists came over and looked at the data and understood immediately what the two engineers had spent a year trying to get rid of. The hiss was the light from the beginning of the universe. Rest there a moment and let that settle, because it is one of the loveliest scenes in the history of science, and it deserves a little quiet. Two engineers trying to build a clean radio receiver, cleaning pigeon droppings out of an antenna, irritated by a noise they could not eliminate. And the noise was the oldest light there is, the glow of the young universe, released when everything was a few 100,000 years old, arriving after 13.8 billion years of traveling at a horn antenna in New Jersey, where two men were trying very hard to make it stop. The two groups published together in 1965, in two papers side by side. One announced the measurement of a mysterious excess temperature. The other explained what it meant, and that was essentially the end of the argument, because the two theories made different predictions about this, and only one of them predicted anything at all. A universe with a hot, dense beginning must have left behind exactly this kind of glow, at roughly this temperature coming from everywhere. A universe in a steady state, eternal and unchanging, has no reason whatsoever to be filled with faint microwave radiation from all directions. There is nothing in that picture to produce it. Attempts were made to explain it away, and they became increasingly strained, and one by one the supporters of the eternal universe changed their minds. Not all of them. Its principal champion never accepted it, and continued to argue for modified versions of his theory until his death in 2001, which is either admirable stubbornness or a cautionary tale depending on your temperament, and probably a little of both. The two engineers received the highest prize in physics for their accidental discovery. The men who had predicted it 15 years earlier did not, and there is some real unfairness in that which is still discussed. And the priest? He lived just long enough. He was seriously ill in hospital in 1966 when a friend came to tell him that the leftover glow had been found, that the traces of the beginning he had proposed 35 years earlier had actually been detected. He died a few weeks later, having learned that he had been right. Rest a moment there gently, because I find that a good ending for him. He proposed an idea that was mocked and defended it for decades against the greatest physicist of the age and against the accusation that he was smuggling in his religion, and he insisted the whole time that it must be judged only on evidence. And then, at the very end of his life, the evidence arrived, and someone came to his hospital bed to tell him. That faint glow, incidentally, is everywhere, and it is worth knowing what it means practically, because it is rather wonderful. It is passing through your room right now. It is passing through you. Billions of those ancient particles of light are going through your body every second, and have been every second of your life, and they set out 13.8 billion years ago when the universe was a glowing fog. In the days of analog television, when you tuned to an empty channel, a small fraction of the static you saw on the screen, perhaps 1% or so, was that radiation. People used to watch a little piece of the beginning of the universe as snow on their television sets, without knowing it. So the argument was over. The universe had a beginning. It was hot and dense, and it expanded and cooled and after a few 100,000 years it became transparent, and the light released at that moment is still washing over us tonight. But that only tells us about the moment the fog cleared, a few 100,000 years in. It says nothing about what happened before, the first minutes, the first seconds, the first fraction of a second, and that, remarkably, is something we now think we understand rather well, and it is where we will finish next time. We will go all the way into the first 3 minutes when every atomic nucleus in your body was forged. We will see why the universe had to expand faster than light in its first instant, and how we found the fingerprints of that in the ancient glow. And we will come at the end to what we still do not know, which is a great deal. But not tonight. Tonight, let the story rest here, with the pigeons evicted and the hiss still hissing, and 2 puzzled engineers in New Jersey about to receive a telephone call that will tell them what they have found. So let your breathing slow, and let the priest in the trenches and the man who called it a blunder, and the radio talk with its careless insult, and the horn antenna in the cold, all grow soft and dim and far away. It was all so recent, and every one of them has already laid down their work and gone quiet, having handed the question on, as we all do, to whoever comes next. There is nothing here you need to carry tonight. It is only a story about people arguing for 40 years about whether the universe had a beginning, and then finding the answer, sitting in a noise they were trying to delete. And I do rather love that, as a shape for a story. The answer was not hiding. It was not far away or faint beyond reach or locked behind some instrument nobody had built yet. It was arriving constantly, from every direction, all day and all night, through every roof and every wall and every person on this planet, and had been throughout the whole of human history. It was in the static on the television. It was in the hiss the engineers were trying to remove. The universe was not keeping this secret. It was announcing it continuously everywhere for 13 billion years, and we simply did not have ears until 1964. And that ancient light is still arriving, right now. Tonight, from every direction at once, having traveled since the universe was young, passing gently through your roof and through your room and through you, on its way to somewhere else, as it has every moment of your life without you ever noticing. There is nothing to do about it, nothing to feel. It is simply there, the way it has always been there, warm and faint and unimaginably old, filling the room around you while you sleep. Sleep now, warm and safe and held, in the faint old glow of the beginning of everything. The story will still be here tomorrow night, with its first 3 minutes and its final mysteries, and we have all the time in the world to follow it, gently, together, all the way in. We can see back to when the universe was a few 100,000 years old, and not one instant further. That is where we left the story. The oldest light there is, released when the cosmic fog cleared and atoms first held together, still arriving tonight from every direction at once. A wall in time surrounding us that no telescope will ever see past. So how can anyone possibly claim to know what happened before that? How can anybody say what the universe was doing in its first 3 minutes, or its first second, when the whole of that era is hidden behind a wall we cannot look through? And yet we do claim it, and with real confidence, and tonight I want to show you why. Because the reasoning is beautiful, and it does not require you to take anybody's word for anything. The early universe left fingerprints, not photographs, but something almost better. It left the recipe of the ingredients, written into the composition of everything that exists, and we can read it. Tonight we go all the way in, to the first minutes of everything, and then all the way out again, to what we still do not know, which is a great deal more than most people realize. But before we go a step further, let me ask you something softly, because it matters. If these quiet journeys through the great stories of our universe help you set down the weight of your day and drift toward rest, then please, take just a moment, right now, before you settle any deeper, and subscribe. It is one small tap, but it means the next of these will find its way back to you on some future restless night, when sleep is far away and you need somewhere gentle to put your mind. And it helps, more than you could possibly know, to keep these stories being made, for you and for all the others out there in the dark tonight looking for a little peace. So if you would, subscribe and stay with me, night after night, as we wander together through the great slow stories of how our world came to be understood. And tell me, if you will, from wherever you happen to be resting tonight, in whatever quiet corner of the world is holding you, where are you listening from? And what hour has it reached where you are? Leave it in the comments below. It is a lovely thing to see all the places and all the hours gathered there together, all of us drifting off beneath the same turning sky, in 100 different countries and 100 different hours, all of us here in the dark at once. And now, let your shoulders come down, and let your breathing slow, and let the whole weight of your day loosen and fall away. Come with me all the way back, past the wall of the fog, into the first minutes of everything. Let us begin by asking how anybody could possibly know. Here is the reasoning, and it is quite simple in outline. We know a great deal about how matter behaves at high temperatures and pressures, not from guesswork, but from experiment. We have spent a century smashing particles together in laboratories at enormous energies and carefully recording what happens. We know how atomic nuclei form and how they break apart, and at what temperatures, and how fast, in considerable detail. So take that laboratory knowledge and apply it to a universe that is very hot and very dense and expanding rapidly, and work out what must happen, what nuclei would form, in what proportions, how much of each. That gives you a prediction, not about something hidden behind the wall, but about something we can measure today, because the material made in those first minutes is still here. It became the raw material of everything, and it is lying around in vast quantities in gas clouds and old stars, and we can measure its composition with a spectrograph. So the test is this: calculate what the first minutes should have produced. Then go and measure what is actually out there. If they match, you have learned something real about an era you cannot see. They match extraordinarily well, and that is one of the great triumphs of modern science, and it deserves the telling. So let us go in and take it slowly, because the timescales are strange, and it is worth letting them settle. At the very beginning, we simply do not know. I want to be honest about that from the start, before we walk backward through the rest. There is a first tiny sliver of time about which our physics has nothing reliable to say, because the whole universe was small enough and dense enough that both of our great theories, the one about gravity and shape and the one about the very small, are needed at once, and they contradict each other. That was the unsolved problem we met in an earlier series, and it sits here too, right at the beginning of everything. So the first fraction of an instant is entirely blank, but shortly after that our physics starts to work, and the story becomes remarkably detailed. The universe is unimaginably hot. Far too hot for atoms, far too hot even for the particles that make up atomic nuclei to hold together. It is a seething soup of the most fundamental particles there are, appearing and annihilating and reappearing, with the whole thing expanding and cooling at a furious rate. And within the first millionth of a second as it cools, those fundamental particles begin to bind together into protons and neutrons. The building blocks of atomic nuclei come into existence. Every proton in your body dates from that moment. There is a puzzle right here, incidentally, and it is a real one that nobody has fully solved. Matter and antimatter should have been produced in equal amounts, and they annihilate on contact. So by rights, everything should have cancelled out and left a universe of pure radiation with no matter in it at all. Instead, there was a very slight excess of matter, something like one extra particle for every billion pairs, and everything that exists, every galaxy, every star, this planet, your body, is made from that tiny leftover surplus. Why there was an imbalance at all is an open question. Rest a moment on that, because it is a strange thing to sit with gently. Almost all of the matter that was ever created was annihilated in the first fraction of a second. We are made of the small remainder that had nothing to cancel against. Now the universe is a few seconds old, and cool enough that protons and neutrons survive, and the next act begins. Between about 1 minute and 20 minutes in, the universe is at roughly the temperature and density of the inside of a star. And exactly what happens inside stars begins to happen everywhere at once. Protons and neutrons start fusing together into light atomic nuclei. But there is a race on. The universe is expanding and cooling rapidly, and fusion only works in a certain window of temperature. Too hot and the nuclei are smashed apart as fast as they form. Too cool and they cannot fuse at all. So there is a window of about 20 minutes, and then the door closes, and whatever was made is what there is. 20 minutes. The entire primordial chemistry of the universe was decided in about 20 minutes. Sit with the strangeness of those timescales for a moment, because they are hard to hold in the mind and worth trying. The universe is 13.8 billion years old, and the events that determined what everything would be made of took place in the first 20 minutes. If you scaled the whole history of the universe down to a single year, all of that would have happened in the first small fraction of a second after midnight on the 1st of January. Everything since has been consequence. Stars forming and burning and dying, galaxies assembling, planets condensing, life appearing on at least one of them. The whole of the long, slow story. All of it worked out from a set of ingredients that were fixed before the universe was half an hour old. And what came out is this. About 3/4 hydrogen, by mass, the simplest nucleus of all, a single proton. About 1/4 helium, and tiny traces of a couple of others, in amounts measured in parts per billion. Then the window closed, and nothing heavier could be made, because building anything larger requires conditions that only appear much later, inside stars. Now here is the test. That calculation gives a very precise prediction, not roughly 1/4 helium, a particular number with decimal places that depends on the details of the physics, and astronomers can measure the actual composition of the oldest and least processed material in the universe, in ancient gas clouds, and in the atmospheres of very old stars that formed early and have not changed much. The measurements match the calculation. The amount of helium is right. The traces of the other light nuclei are right, in amounts down to parts per 10 billion. Rest there a moment and let that land, because it is quite staggering when you consider what has just happened. Somebody sat down with the known behavior of nuclear physics, applied it to a hypothetical hot, dense, expanding universe, calculated what should have been produced in the first 20 minutes of time, and then astronomers went out and measured the sky and found exactly those proportions. That is not a vague agreement. That is a theory about the first minutes of the universe, making a numerical prediction and then having it confirmed to several decimal places. And notice something rather wonderful. The hydrogen in the water you drank today has been hydrogen since the universe was 3 minutes old. It has never been anything else. It was made in that 20-minute window, and it has been drifting through space and collapsing into stars and floating in clouds and eventually falling as rain onto this planet. And it is in you now, and it will be in something else afterward. And every one of those atoms is 13.8 billion years old. That is not poetry. That is the literal chemistry of it. Now, the theory had a spectacular success there, and by the 1970s it was firmly established. But it also had some awkward problems, and I want to tell you about 2 of them, because the solution proposed for them is one of the strangest and most audacious ideas in modern physics. The first problem is about how uniform everything is. That ancient glow, the light from the clearing of the fog, comes from every direction, and when it was measured carefully, it turned out to be extraordinarily even. The temperature of the sky in one direction and the temperature in the opposite direction are the same to about 1 part in 100,000. That seems tidy and unremarkable until you think about what it implies. Take a patch of sky on one side and a patch on the exact opposite side. The light from those 2 patches has been traveling toward us for nearly the whole age of the universe, which means that at the time it was released, those 2 regions were so far apart that light could not possibly have crossed between them. Not then and not in all the time since the beginning. They have never been in contact, not once, ever. No signal, no light. No influence of any kind has ever passed from one to the other. So how do they have the same temperature to 5 decimal places? 2 things reach the same temperature by being in contact and exchanging heat, like a cup of tea cooling in a room. But these regions have never touched. They should have no reason whatsoever to match, and yet they match almost exactly, everywhere in the sky, in every pair of opposite directions. That is the first problem, and it is serious. The second is about the shape of space. The theory allows the universe to be curved on the largest scales in one direction or the other, or to be exactly flat, meaning that space obeys ordinary geometry across the whole cosmos. Measurements say it is flat, or so close to flat that we cannot detect any difference. And that is far more surprising than it sounds, because flatness is unstable. If the universe had been even slightly off from perfect flatness at the beginning, the expansion would have amplified that difference enormously over billions of years, and by now it would be wildly curved. To be as flat as we observe today, the universe must have been flat at the beginning to something like 1 part in a very large number indeed, which is a fine coincidence if you like coincidences and physicists do not. And then, in the early 1980s, a young physicist who was working on something else entirely realized that a single idea would solve both problems at once, along with several others. The idea is called inflation, and it is this. In an unimaginably brief instant, very early on, long before the first second was over, the universe expanded by an enormous factor, not gradually, explosively, doubling repeatedly, so that a region far smaller than a single atomic nucleus was stretched to something larger than a grapefruit in a period of time, so short that writing the number down requires a great many zeros after the decimal point. And then it stopped, and the ordinary steady expansion we see today took over. The numbers involved are so far outside ordinary experience that they stop meaning much, but let me try to give you a feeling for them anyway, gently, because the scale is part of the wonder. The whole episode was over in less time than it takes light to cross an atomic nucleus. Not less time than a blink. Less time than a beam of light needs to cross the very center of a single atom. And in that unimaginably brief moment, the universe grew by a factor with something like 26 zeros in it. To put that another way, if you took something the size of a single grain of sand and expanded it by the same factor, it would end up considerably larger than the entire observable universe is today. That is what is being proposed. And it sounds outrageous, and it is outrageous. And the reason serious people take it seriously is not that it sounds plausible, but that it solves several separate problems at once with a single mechanism, and then makes a prediction that turned out to be right. Now watch how neatly that fixes everything. The uniformity problem dissolves because before inflation, the entire region that became our observable universe was tiny, small enough that everything in it was in easy contact and could reach a common temperature. Then inflation took that small, thoroughly mixed patch and stretched it enormously, flinging its parts far apart. So the regions on opposite sides of the sky do have a shared history. They were neighbors once in intimate contact, and then they were separated by an expansion so violent that they can never communicate again. The flatness problem dissolves too, for a reason you can picture easily. Take any curved surface at all and blow it up enormously, and any small piece of it becomes indistinguishable from flat. The surface of the Earth is a sphere, and yet a field looks flat, because we are very small compared to the whole. Inflation stretched the universe so violently that whatever curvature it had was smoothed out to nothing detectable. Rest a moment there, because it is an extraordinary idea, and it is worth admiring even as we hold it loosely. A single event over in less than an instant explains both the uniformity of the sky and the flatness of space, and it comes out of reasonably natural physics rather than being invented from nothing. But an idea that elegant still has to make a testable prediction, and inflation makes a marvelous one. If everything we can see was once a tiny patch, then the tiny random fluctuations that exist in any quantum system, unavoidable, the sort of jitter that we know is always present at the smallest scales, would have been stretched by inflation to enormous size. Which means the universe should not be perfectly uniform. It should have a very faint pattern of slightly hotter and slightly cooler patches at a particular range of sizes and with a particular statistical character, all inherited from quantum jitter in the first instant. And those tiny variations in density would then be the seeds. Slightly denser regions pull in more matter by gravity and grow denser and eventually collapse into the first stars and galaxies. Everything that exists would have grown from those original ripples. So the prediction is that the ancient glow should be almost uniform, but not quite, with a faint pattern at 1 part in 100,000. Finding that required going to space because the atmosphere is in the way. A satellite was launched in 1989 to map the ancient glow across the whole sky at very high precision, and that measurement was extraordinarily difficult because of the size of the effect they were hunting. They were looking for temperature differences of about 1 part in 100,000, across a sky whose overall temperature is only a few degrees above absolute zero. That is like measuring the temperature of a room and needing to detect a variation of a few thousandths of a degree between one wall and the other, from orbit, through your own instrument's warmth, with the Earth and the Sun and our own galaxy all glowing in the way and needing to be carefully subtracted out. They also had to subtract our own motion, because the Earth and the Sun and the galaxy are all moving, and that motion slightly warms the glow in the direction we are heading and cools it behind us. That effect is far larger than the pattern they were looking for, and it had to be removed first. And in 1992, the results were announced. The glow is not perfectly smooth. There is a faint mottling hotter and cooler patches at almost exactly the level predicted, with the statistical character that inflation implies. Later missions mapped it in far finer detail, and the pattern in those maps has become one of the most information-rich images in all of science. From the sizes and spacings of those patches, cosmologists can extract the age of the universe, its overall composition, the density of ordinary matter, and a great deal more, because the pattern is essentially a photograph of sound waves that were rippling through the plasma of the young universe when it turned transparent. Yes, sound waves. Before the fog cleared, the universe was a hot, dense fluid, and pressure waves ran through it, exactly as sound runs through air. When the fog lifted, those waves were frozen into the pattern of hot and cold spots, and we can still see them. The ancient glow is a photograph of the last sounds of the young universe. Rest there a moment and hold that, because it is one of the loveliest facts in cosmology. Space is silent now, and always has been in our experience, because there is no air out there to carry sound. But in the first few 100,000 years, the universe was dense enough to ring, and the ringing is still visible, frozen into the sky. And from its pitch we have measured the age of everything. 13.8 billion years, incidentally, with an uncertainty of well under 1%. That number comes largely from that pattern. And there is one more thing in those faint patches that I would like you to carry to sleep with you, because it connects the very largest thing to the very smallest, and I find it quietly astonishing. Those slightly denser regions were the seeds. Gravity took each one and pulled more matter in, and over hundreds of millions of years they grew and collapsed and became the first stars, and then the first galaxies, and eventually every galaxy that exists, including ours, including the cloud of gas that became our sun, including this planet. Which means that if you trace the existence of our galaxy all the way back, you arrive at a random quantum fluctuation, a piece of unavoidable jitter at the very smallest scale, blown up to cosmic size in the first instant of everything. Every galaxy in the sky is an amplified piece of quantum noise. The structure of the entire universe, the vast web of galaxies and clusters and voids, is a photograph of tiny random ripples that existed for less than an instant, 13.8 billion years ago, stretched to enormous size and then filled in with stars. So the picture holds together. The composition of the light elements confirms the first minutes. The ancient glow confirms the fog clearing. The ripples in that glow confirm inflation and account for the origin of every galaxy. And the whole thing is consistent, cross-checked from several independent directions, and it works. And then, in 1998, something happened that nobody expected, and it is the last major turn in this story. Two competing teams of astronomers set out to measure how fast the expansion of the universe is slowing down. Everyone assumed it must be slowing, because gravity pulls everything together and should be gradually putting the brakes on. The question was, only how much, because the answer would tell us whether the universe would expand forever or eventually fall back. They used a particular kind of exploding star as a standard candle, a type that always detonates with very nearly the same brightness, so that its apparent dimness reveals its distance, in the same way the pulsing stars had done in our first night. Both teams found the same thing, independently, and neither believed it at first, and both spent months hunting for errors. The expansion is not slowing down, it is speeding up. The way they saw it is worth a sentence, because it is quite direct. Those distant exploding stars were fainter than they should have been. Fainter means further away than expected, which means that in the billions of years since that light set out, The universe has grown by more than a steadily slowing expansion would allow. Something has been pushing it along, and it has been pushing harder as time goes on. In the early universe, when everything was closer together, gravity was winning, and the expansion really was slowing. Then, a few billion years ago, the two effects crossed over, and the pushing began to dominate, and the expansion started to accelerate. It is accelerating now, and it will keep accelerating. Something is pushing space apart, and its influence is growing as the universe grows. And by the accounting, it now makes up the majority of everything there is. We call it dark energy, which is a label rather than an explanation. We do not know what it is. And here is the lovely twist I promised you last night. The mathematics of dark energy looks very much like that extra term the great man added to his equations in 1917, and then withdrew in embarrassment as the blunder of his life. He put it in to hold the universe still. It turns out something like it is really there, doing the opposite of what he wanted, pushing the universe apart faster and faster. His mistake was not the term, it was the sign and the reason. So where does that leave us tonight? It leaves us with a picture that is remarkably solid in its middle and remarkably open at both ends. We know, with real confidence, what the universe has been doing from about a second old to the present day. That story is confirmed from many independent directions, and it holds together beautifully. And we do not know what happened before that first instant, or what caused it, or whether there was a before at all. The question of what came before the beginning may not even be a meaningful question if time itself began then, in the way that asking what is north of the North Pole is not a meaningful question, or it may be perfectly meaningful, and we simply lack the physics. Nobody knows. We do not know what dark matter is, and it appears to be several times more abundant than everything we can see. We do not know what dark energy is, and it appears to be the majority of everything, which means that our best current understanding says the overwhelming bulk of the universe is made of two things we cannot identify. Everything familiar, every star and planet and person and atom, all the material this entire series has been about, is a small minority of the total. Rest there a moment and let that be a comfort rather than a worry, because I think it is one. It means the story is nowhere near finished. Somebody at some point is going to work out what those things are, and it will be as large a shift as anything in these 3 nights. There is a great deal left to find, and it is worth saying plainly before we finish what the theory does not claim, because a great deal of confusion attaches to it. It does not claim to explain where the universe came from. It never has. It is a description of how the universe developed from a very hot, dense early state, and it is extremely well supported, and it says nothing whatsoever about why that state existed, or what preceded it, or whether anything did. It does not describe an explosion in space. There was no bang, no center, no outward flying debris, no surrounding emptiness for anything to expand into. Space itself expanded everywhere at once. Every point in the universe was at the beginning. The place where it happened is the place where you are lying, and also everywhere else. And it is not, despite the name, one dramatic moment. It is a process that has been running for 13.8 billion years and is still running tonight. The universe is still expanding. In a real sense, it is still happening quietly all around you. Those are the honest boundaries of it. Within them, the theory is one of the best supported in all of science. Outside them, we are as ignorant as anybody has ever been, and that is fine, and there is no hurry. And now let us come to the end. Look back over the whole arc of it, if you will, as you drift. 100 years ago, the universe was one galaxy, static and eternal, with no history and no beginning. And then a woman measuring photographic plates in a room where she was not allowed to touch the telescope found a way to measure distance, and the universe filled with galaxies. And a graph was drawn showing that they are all rushing apart, and the eternal universe ended. And a priest who had fought in the trenches ran the film backward and said there must have been a beginning, and was told his physics was abominable. And a rival theory fought it for 20 years and gave it its name as an insult. And 2 engineers cleaning pigeon droppings out of an antenna found the light of the beginning arriving from every direction, and the argument ended. And people calculated what the first 20 minutes should have produced, and went and measured the sky and found it. 100 years. That is all. Somebody alive today could have been born into a universe that was one galaxy, eternal and unchanging, and could be lying in bed tonight in a universe of 2 trillion galaxies with a measured age and a photographed infancy. And every single piece of it came from people looking very carefully at faint light and writing down numbers. So let it rest now, all of it. Let them rest, all of them. The woman with her glass plates and her failing health, who found the measuring stick and died before anyone understood what she had given us. The observer on the mountain with his exclamation mark. The Russian who died of typhoid without knowing his equations described the real world. The priest, ill in his hospital bed, being told at the very end that they had found it. The man who named it as a joke and never accepted it. The 2 engineers who tried for a year to get rid of the oldest light in the universe. They are all gone now, and between them, in a single century, they worked out where everything came from and handed it on, as we all do, to whoever comes next. And out there tonight, while you rest, all of it is quietly going on. The galaxies are drifting further apart, a little more every second, patiently, in the great dark. The ancient glow is washing through your room from every direction, as it has every moment of your life, and the hydrogen in the water in your body, made in the first 3 minutes of everything, is doing what it has been doing for 13.8 billion years, which is simply carrying on. None of it needs your attention tonight. It has managed without supervision since long before there was anyone to supervise it, and it will keep going while you sleep, and it will still be going when you wake. So let your breathing slow one last time, and let the plates and the graphs and the pigeons and the first 3 minutes all grow soft and dim and very far away. The story is told, or as much of it as anybody has yet. There is more, and somebody will find it, and it does not have to be tonight, and it does not have to be you. Let the whole sky settle now, and slow, and quieten. Let the galaxies drift apart at their own unhurried pace, a few centimeters here, a few kilometers there, patient beyond any patience we can imagine, as they have every second since long before this world existed. Let the ancient glow wash through the room without needing to be noticed. Let all of it get on with itself, and let them rest, the people who worked it out. The woman with the glass plates, the observer on the mountain, the mathematician who died young, the priest in the trenches and then the pulpit and then the hospital bed, the 2 engineers with their bucket and their brush cleaning out the antenna. Not one of them set out to discover where the universe came from. Every one of them was simply doing careful work patiently and paying attention, and it added up to this. You are made of the oldest things there are. That is the last thought I will leave you with, and it is not a figure of speech. The hydrogen in you was made when the universe was 3 minutes old. The heavier atoms, the carbon and the oxygen and the iron, were forged inside stars that lived and died before our sun existed, and were scattered into space when those stars ended, and gathered up again into this world, and eventually into you. There is nothing in your body that was not made somewhere out there, in the first minutes of the universe, or in the heart of a star. You are not separate from any of this. You are a piece of it, lying quietly in the dark, having become briefly able to wonder where you came from. And now you know as well as anybody does, so there is nothing left to work out tonight, nothing to hold, nothing to solve. The oldest question there has been answered as far as it can be answered so far, and the rest can wait for people not yet born. You can put it all down now. Sleep now, warm and safe and held, made of ancient things, on a small world in a quiet corner of a universe that has been expanding gently for 13.8 billion years, and will still be expanding, without any fuss at all, when the morning comes.